Hey guys, we are starting chapter 11, which is all about finding surface area volume of three-dimensional figures. So like chapter 10, we found the area of a rectangle, but now we're going to be able to find like the surface area of a rectangular prism. Remember 3D things are something that you can physically hold, like they're objects, right? Here are some of the main ones that we'll be dealing with. Spheres, cubes, cylinders, pyramids, and so forth. So our first kind of big idea here is a polyhedron, and that is a three-dimensional shape or figure that is made solely of polygons. So all of its faces, which are just the shapes that compose this three-dimensional figure, are just made up of straight lines. So like triangles or rectangles. There's just no curves, everything's straight. They're polygons, right? So that red rectangle I just outlined would be a face. Now an edge is where two faces meet. So all these segments here are my edges. Even these ones that go backwards, those are all edges. And then your vertices are your corners, so where your edges meet. Those are your vertices. So the first part of this lesson is just identifying how many faces, vertices, and edges are in the polyhedron. So let's try it out. So faces, vertices, and edges. I'm going to take this first one kind of slow because for some people, especially since I can't show you examples of what we're dealing with in class, I'm just going to try break it down as simply as possible. So faces, remember, are how many sides does the figure have? Right now we're looking at essentially like a dice, like a rolling dice, a cube. Think how many sides does a dice have? Well, I hope you're thinking 6. So there's 4 sides. And then a top and a bottom. So I have 6 faces. How many vertices? We'll just count your corners. I have 1, 2, 3, 4 on top, 5, 6, 7, 8 total. And then your edges. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So pretty straightforward, but still can kind of get confusing if you don't look at it carefully. And again, we're just practicing with different shapes. So this here, just for practice, think of Egypt, pyramids, right, to come to a point. So this would be you name it by its base, a rectangular pyramid. Because you name polyhedrons by their base shape. So again, name how many faces, vertices, and edges there are. So your faces, I have my bottom base, then how many walls are there to my pyramid? 2, 3, 4, so a total of 5 faces. Okay, now how many vertices? 1, 2, 3, 4 on the bottom and 1 top, so 5. And then how many edges? 1, 2, 3, 4 on the bottom, 5, 6, 7, 8 on top. Well, that make up your sides. Now this example over here on the right is a prism because my sides don't come to just one distinct point. So this would actually be a triangular prism because your base shape is a triangle. Because do you guys see how these 2 red triangles I outlined are parallel? So that would be my base shape. So a triangular prism. So again, let's count out how many faces, vertices, and edges we have. So I have, there's a face, There's another face. Those are my bases. So 2. And then I have 3 walls that make up my sides. 4, 5. That's 4, excuse me. And then this bottom one would be 5. So 2 bases and 3 walls give me a total of 5 bases. Okay, now count your vertices. 1, 2, 3, 4, 5, 6. And then your edges. So 1, 2, 3, 4, 5, 6. Oh, sorry guys. All right, where were we? 6, 7, 8, 9. 9 edges. So now instead of having to count that out every single time, there was a Swiss mathematician named Leonhard Euler, it looks like Euler, but it's Euler, that discovered a relationship amongst the faces, vertices, and edges. I mean, for the most part, our examples are pretty straightforward, but there are some polyhedrons that are actually pretty complex, where this formula would actually benefit you. So Euler's formula is the sum of the faces plus vertices is equal to number of edges plus 2. So your faces plus vertices equals your edges plus 2. So it says how many vertices, edges, or faces does this polyhedron have, and then use Euler's formula to check your answer. So again, kind of the same process we were doing before, faces, vertices, edges. This example, if you guys look, here's our base shape. It's a hexagon, and since my sides don't come to a distinct point, it's a prism, so it's a hexagonal prism. Okay, now let's count out our faces. So I have a top and bottom, which gives me 2. Now count out your walls. 3, 4, 5, 6, 7, 8. So a top, bottom, and 6 walls for a total of 8 faces. Our vertices, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the edges, be systematic about it. So the top is going to have 1, 2, 3, 4, 5, 6. Then my bottom's going to have 7, 8, 9, 10, 11, 12. And my walls, 13, 14, 15, 16, 17, 18. For a total of 18. Now let's plug into our formula. See if it all works out. Faces plus vertices equals edges plus 2. 20 does equal 20, so yes, we did do that correctly. All right, let's try this again. Use Euler's formula to find the missing value. So I'm going to start off with the formula faces plus vertices equals edges plus 2. And I'm looking for the amount of faces I have. So I'm going to leave f just as a variable because I don't know what it is, plus 20, because that's how many vertices I have, equals my edges, 30, plus 2. Now it's just a straight computation. Faces plus 20 equals 32. Faces equals 12. If you want to look that shape up and tell me what it is, write it down in your packet and show me tomorrow, I will give you a bonus point. So if you can figure out what that polyhedron is called, a bonus point for you. This guy right there. Okay, now this time, they're telling us we have 7 faces, 2 of which are pentagons, and 5 of which are rectangles. Find the amount of vertices. So they're not giving you a picture, but I think you should draw one. Otherwise, how are you going to figure out how many edges you have? So I'm going to erase this so I have a little bit more room here. So if I'm thinking I have 2 pentagons, to me that that means that's my top and my bottom. That's my base. So let's see here. Bear with me, guys. I'm not much of an artist, so I'm going to try to draw a pentagon to the best of my ability. All right. Connect it. So there's one of my bases. Go ways back here. Something like this. Connect these guys. Now I'm going to connect my two pentagons. So, I would say that kind of looks like a pentagonal prism. I cheated though since I knew what it was, so you guys would have an actual visual. This is what I was going for. I just flipped it on its side. But my two pentagons are my bases, and then I have 5 rectangles, choose a different color, making up my walls. All right, now let's use our formula here. So I have faces plus vertices equals edges plus 2. So I know I have a total of 7 faces. Now let's count out we're looking for vertices, even though now we can figure it out. And edges, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 plus 2. 7 plus vertices equals 17. So I have a total of 10 vertices. And we can obviously check that because look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we did do it right. Nice work, everyone. And then the lesson finishes up with cross sections. Now you see this a lot in science, especially like cross sections of the human body, or in, for instance, nature with plants and whatnot, so you can figure out what's going on inside things. Here is a cross section of the earth, an onion, and the brain, and so forth. So a lot of careers use cross sections, but how we introduce it is if you take a cross section of a 3-dimensional figure, it results in a 2-dimensional one. So if I cut this triangular prism like so with this yellow blade, if you want to think of this as a blade, it's cutting it. What is the shape I see? It's a triangle. Well, obviously you guys just saw me try to draw a pentagonal prism and it was awful. So there's a quick little film we're going to watch together.
Math Shorts. Slicing solid, 3-dimensional figures results in different 2-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the 2-dimensional cross-section is a circle. Any way you slice it, you can get 2-dimensional shapes from 3-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle.
So do you guys see how we started off with a 3-dimensional pyramid, but when we cut it to find the cross-section, it results in a 2-dimensional figure, so like a triangle. Okay? Almost not this little video.
Remember, you're slicing a solid, 3-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the 2-dimensional shapes that result from slicing solid, 3-dimensional figures is important for geometry and ninjas.
All right.
That's it. You can
So
get
I think gave a better, hopefully a better idea second here, so I'm not so loud next to the computer. Okay, I think that will give you a better idea of what a cross section is, since it's hard to show you on just the video what I'm trying to talk about. So now we're going to try to do some of these on our own. So the first one's just an example. It says draw a cross section from a vertical plane that's intersecting the front and right faces of this cube. So you got to think, here's your front wall and there's your right wall. And my plane right here is in yellow. So I'm cutting it with this yellow blade. Think that this is your blade of your knife. Now what shape does it result in? If I were to draw that outside here, if I had a little magic, this would be a rectangle. So that would be the cross section that's formed. Okay, let's try another one. So it says, draw the cross section formed by a horizontal plane intersecting the left and right faces of the cube. So I cheated again. I have a little knife here, but here's my left wall, here's my right face, and then here's my knife cutting, 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 on down through it. So what shape does this result in? Well, again, just watch. If I draw that outside my cube, again, I'm left with a rectangle. Or I guess since it's a square, the more accurate name would be a square, because all your sides are the same. Okay, then we're gonna get a little fancy here. It says, what's the cross section formed by a horizontal plane parallel to the top and bottom faces? Okay, here's your top, and here's your bottom. So you gotta think you're cutting, so you're parallel between them, so you're not gonna touch your top and bottom. So again, I'm gonna try to draw my plane here, and then I'm gonna be cutting it like this. It's like you're cutting open a hamburger bun that's shaped like a hexagon. So what shape are you resulting in? Well, you're resulting in a hexagon. So if you were to cut that in half, you would end up the cross section of a hexagon. Now this last one, what is the cross section formed by a vertical plane parallel to the front and back walls? So here's your front, there's your back wall, and your front would be this one right here. Now you're taking a plane and you're cutting in between there, so you're not going to touch your front and back wall. So again, here's your knife coming through, it's coming through, it's coming through. Kind of think of like holding a paper the hot dog way. So now if I'm cutting this in half, what shape will I result in? Well, you're going to end up with just a rectangle again. I know it's really hard to visualize when you're not seeing the shapes, but I will show you in class. Next time we have class together, it will make a little bit more sense that way. Thank you for watching. You have a book assignment, a worksheet, and good luck. I'll see you next time.